8%, so I don't want to risk it yet. What I do want to do is actually turn the time over to you guys for a little bit before we get diving into material. I want you guys to take the spotlight, introduce yourself, your name, your major or your career path, and that fun fact that you shared with me or any other ones that have popped up since. If you want to share that with the class, that's great. We had a lot of people on Tuesday. You guys might notice the class is like almost half as full as it was on Tuesday. That happens quite a bit. Like I said, we've got this recording of the class, and last fall, I had 2 students, 2 of my top scorers, showed up on the first day, the midterm, and the final. And so I know that you guys can do it by using the recordings, but I want to encourage you to take advantage of whatever setting is best for you. Feel free to come in late. Feel free to come in halfway through. Feel free to leave early, whatever you need to do, and use the recordings for whatever else you need. But if you guys would just introduce yourself to the rest of the class and to me if I haven't met you yet. I'll get to know your names if I don't know them already, I promise. And then we'll dive into some material. So I think we'll start over here and just kind of snake our way through.
I'm Jordan. I think, what was another factor?
What's your major or your career path?
I'm studying to be a biochemist. And fun fact is I speak Spanish.
Tu hablas español. That's all I can say. Awesome. Thank you, Jordan.
Hello, my name is Miara, and I graduated this May at the University of Utah with a degree in health study and policy, but I want to apply to medical school, so I'm finishing up my pre-med science classes. And my fun fact that I had written was I cut my hair this summer. These are just extensions, but that was my fun fact.
How does it feel to have shorter hair?
I like it because I dyed my hair a lot, so it's very damaged. So
Mm-hmm.
I grow it out to be healthy.
Fresh start.
Yes.
Awesome. Well, congratulations, and good to have you here, Nia.
So I also graduated from the University of Utah with a degree in psychology. I'm a pre-PA now. I did apply to PA schools. Haven't heard back, so I'm still taking more classes. Fun fact, I went from cheating in games to coding games.
That's right. You said you coded a game on Roblox, huh?
Yes.
Is it a fun game?
Oh, it is, yeah. And you actually make a lot of money on it.
No way.
Yeah.
You're getting paid by someone else to do it?
No, like I code it and then if people play it, they get money. Or I get money.
How can we play it?
You just like download Roblox and you search up the game and like you play it.
You want to tell us what it's called?
Uh,
Is there a paywall to play your game, or is it just like the ads that we watch pay you?
so it's mostly like if they pay money and like buy stuff from the game.
Right, right.
But yeah, it's an Obby. It's called Obby.
Obvi.
Yes.
Cool. Well, congratulations. Great job, and good to have you, Rusla. We're going to go up front, and then we'll snake back to you.
Hi, I'm James. I'm a biology major, thinking about going into food safety. I came to Utah from a town called Manhattan, Kansas, and yes, we do call it the Little Apple.
I love that. Thank you, James. Good to have you.
My name's Roha. I'm pre-PA. I've graduated from the U already. Just taking extra classes. I'm Adelia. I'm a biochem major for U. Want to go to medicine. I can't remember my fun fact from this last one, but last semester I said that I was from Virginia.
Oh, that is a fun fact. And you're living here on purpose?
Yeah. I like to ski, so.
Yes. I think that was your fun fact,
Oh, yeah.
that you
maybe
ski
it
and
was.
snowboard.
Yeah.
Yeah. Awesome. Thanks, Cordelia. Thank you, Roha. Good to have you guys back.
My name is Connor. I'm getting my degree in business, but I'm doing the prereqs to go to dental school. I want to become like an oral and maxillofacial surgeon. And then my fun fact is I spent the summer interning in Washington, D.C.
That's right. I remember you had to skip your final exam to head out
I
there.
did, yeah.
How did it go?
It went really amazing. It was incredible.
Yeah?
Yeah.
It didn't sway you on going to dental school?
It did a little bit. They offered me a job, but
Oh, yeah.
I still got to finish up school at the very least.
Sure. Good point. Awesome. Well, we're glad you made it back, Connor.
My name is Brian, and I am pre-pharmacy. Fun facts, currently work for the U, and I have a few publications within pharmacy.
Nice.
That's about it.
That's pretty cool.
Did you make stuff or?
It was more so like, kind of like a formulary tip sheet within the U, pharmacy-wide, so kind of across the system.
That's awesome. Congratulations. Good to have you, Bryce. Just your name, your career path of your major, and your fun fact if you got one.
I can't think of a fun fact right now. My name is Killian. I'm doing chemistry. I guess I just could say that I like to do research, so starting research in a month or two, or probably less than a month. Just over here. Feel free to join.
Yeah, actually, I want to pitch something to you guys. That was a good reminder. Thank you. Let's move right here.
My name is Christina. My major right now is material science engineering. And my fun fact is that I'm probably going to change my major, and I don't know what my career path is yet.
That's okay. It's a good place to be. You're young. You got time to figure it out. You can always come back and change it later. Good to have you back, Christina.
I'm Kayla. I also have a degree in psychology from the U, and I'll also apply to med schools next summer. And I like playing music. That's my fun fact.
Anything specific?
I grew up playing the saxophone.
Wow.
So yeah, I have a little student model soprano now. So my alter ego is kind of Kayla G.
Yeah.
Kenny G. So yeah, I like jazz and just contemporary stuff.
Cool. That's awesome. Good to have you, Kayla.
My name's Cameron. I'm a pre-vet. My major is the management of emergency services and assisted patient care. I've got one semester after this one, and as of this morning, my applications to veterinary school are being processed by programs.
Congratulations. It's that nerve-wracking spot, right?
It sucks.
Where you're just waiting.
I almost grew up.
Yeah. Yep. Yeah. Well, hang in there. We got your back. Awesome. Good to have you, Cameron.
My name is Cooper. Last one, unless everyone calls me. I also graduated from the U a couple years ago. Worked for a couple of years as a paramedic, and now I'm hoping to go to some kind of graduate school. So I guess if I'm back with me, yeah, as a paramedic, still do that when I'm not here. And I also worked like every food service job. I've been a barista, I've been a line cook, I've been a cheesemonger, I've done it all. If it's something in a commercial kitchen, I've probably worked that.
Wow. How's it compare to being a paramedic?
I prefer being a paramedic, but
Yeah.
depends on what you're into.
Do you have a favorite or least favorite part of being a paramedic?
My favorite part is when I actually get to help people.
Yeah.
And my least favorite part is everything else.
Yeah. Awesome. Cooper, I've got another student with the first name Cooper this semester, but 2 O's instead of a U, so a little different. I'm sure I'll be able to distinguish you guys. Good to have you back.
My name's Matt. I'm actually just graduated from last semester, but I'm taking some additional classes because it was convenient. So currently, technically, I'm a chemistry major, but I don't like chemistry all that much. I hate to say, but
No, I can relate.
I guess I could do my fun thing.
Awesome. Good to have you back, Matt.
My name is Luis. I'm majoring in biology, and a fun fact about me is that I do garden design on the side.
For yourself or for other people?
For other people.
Garden design. So you get hired by people to design their gardens.
Yeah.
That's a fun fact.
Yeah, it's fun. I've been doing it for a year now, so I've done it for 4 years, but I started doing it for myself last year, so it's been a lot of fun.
Now, Luis has also been running a research project in biology, monitoring growth response hormones from cottonwoods.
No, mainly And so what I'm doing is measuring how the VOC emissions that plants produce change based on how much mycorrhiza is in the soil.
Very cool. So you love being outside and you like working with plants.
Yeah.
That's what I'm hearing. Cool. Is this a company you work for that plants gardens?
So I started working for a nursery about 5 years ago, and I've kind of branched out in all sorts of directions. So I'm also working on my arborist certificate right now, and I'm hoping to take the test by the end of the year. But I've also done some design for them as well. And then last year, some people that I worked with, they were like, "Do you want to design our yard for us?" And then I did it. I basically designed their yard and did all the installations and everything. And then from there, the ball just kept rolling. And finally, this year, I kind of did all the paperwork and got an LLC going.
You're a small business owner.
Yeah.
That's very cool. Awesome. Thanks, Luis.
My name is Abram. I'm going to New Delhi right now. I'm pre-med. Fun fact is I have a dog.
What kind of dog?
Burmese
Oh yeah, big dog. What's his name?
His name is Luffy. Yeah.
Awesome. Thanks, Abram. Now, Abram, I think you're holding your molecular stencil.
Oh yeah, I do.
Would you recommend it to your class?
Yeah, it makes it so much
If
easier. I'm so bad drawing.
if you're drawing on a tablet, you guys know you can like press and hold and it auto corrects those shapes for you. If you're anything like me, you're gonna get really good at drawing your hexagons this semester, and then you're gonna get a lot worse at it if you keep doing it. So my hexagons are terrible. Abram's got stencil perfect hexagons. Cool. Thanks, Abram.
I'm Brett. I have a bachelor's in kinesiology. Fun fact, I'm trying to go to med school for endocrinology, so hormones and all that fun stuff.
Are you excited about having to change your molecule for this semester, Brett?
I'm not. I was going to ask you to do one very similar, but
I actually said that the other day because of
I think it was
you.
directed to me.
It was. I wasn't too worried about anybody else. And you know what? I'm not against you doing that same molecule on the side and submitting it with me. I'll give you feedback, but I want to see another one. I want to see one that's cooler. Okay.
Cool.
No, sorry. You're right. You're right. I want to see you branch out though. I think it'll be good. Cool.
My name is Jacob. I graduated a while ago with a degree in materials engineering and decided I didn't want to do that forever. And so taking the prereqs for med school as well. Planning on applying spring 26, which I'm excited about. Excited to not work and take classes at the same time. It sucks.
Yeah. Are you doing that right now?
Yeah. It's not that fun.
What are you doing for work?
I work for a defense contractor as a materials engineer. It's good, it's just a grind. But fun fact, I have lived in 3 countries.
Yeah. You want to share what they are?
Sure, yeah. I lived in Scotland for 3 years and then Qatar for 3 years.
Wow.
So I can relate a little bit to your Arabic learning journey.
Sure, yeah.
Yeah, I took it in 8th grade and it's been too long. It's regressed back to hieroglyphics, to be unfortunate.
So at what point did you live in Scotland and Qatar?
Scotland was 2nd grade through 5th grade, and then Qatar was 7th through 10th, pretty much. So
Sure.
I did some high school over there.
So you did some of your developmental years
Yeah,
overseas.
It was good.
Yeah?
Really good.
So that was not your choice, by the way.
Yeah, no. Yeah, it was forced upon me. But I liked it. It was good.
Yeah, awesome. Justin, right?
Jacob.
Jacob. Thank you, Jacob.
I'm Russ. Went to school originally for healthcare administration. Worked in hospitals for a while. Love hospitals, love healthcare. Do not like healthcare administration anymore. So I'm getting ready to go back to med school. Planning on applying next spring as well. My fun fact is last year I came across a documentary called California Typewriter, which is all about these people that use typewriters in modern times. And it got me really interested in it, and now I've kind of started a small collection, restored a couple old typewriters, and my wife thinks I'm insane. I kind of feel insane when I do it, but in the age of AI, it's kind of therapeutic to look at old typewriters. So.
Sure. So you did say you have a collection.
I have 2.
Okay. Because I'm wondering how much of your attic is taken up by typewriters.
Yeah.
And are you planning to sell them?
No, not really. I mean, some of them can be worth a lot of money. It's kind of crazy.
Hmm.
I kind of just like having them around. They're kind of like, there's car guys, and I guess I'm a typewriter guy.
Yeah.
I don't know what that means. But.
So is this like when you get writer's cramp on one of your typewriters, you gotta just leave it where it is, so you go over to your other typewriter to finish something else?
Yeah, kind of.
I know I haven't used a typewriter in a long time, but I have used one.
It's crazy how you can tell the difference. Like, the cool thing about them is like the engineering that goes into it. And every time I sit down and use, like, I've got this one that was made in East
Oh, heads up
Germany
behind you if you want to scoot in just a
in the
little bit.
40s, and it's like amazing the engineering of this thing.
Mm.
And when I picked it up from this person, I don't think it's been touched since the 50s, and it works great. And it's just like this perfectly well-maintained little machine that just goes and goes.
Mm-hmm.
It's pretty cool.
Nice. Cool. Thank you, Russ. Good to have you back. All right, I want to turn the spotlight to a couple that we skipped over. So if you would share your name, your career path or your major, and if you got any fun facts.
My name is Axel. I'm intermediate for biology.
You got a dog?
Yeah.
What kind of dog you have? A lab. Golden lab? Black lab? Yeah, cool. What's their name?
Mia.
Mia. I thought you said meow. And I was like, that's a funny name for a dog. That's good. Thank you, Axel. Good to have you back. And share your name, your major, your career path, and a fun fact if you got it.
Yeah, I'm Courtney. I majored in public health at UVU. I'm taking prereqs for med school, and I love to kayak.
Awesome. Thank you, Courtney. And I did not forget about you.
Hi, my name's Bailey. I'm pre-med right now. Fun fact, I'm a medical laboratory scientist, and I work specifically in autoimmune immunology.
Nice. Very cool. Do you like that?
Sure.
Cool. It's good to have you, Bailey. Thank you. All right. I want to do a quick little poll. How many? Oh,
Sorry, could you say that one more time? You just pronounced it really good.
no, and that's why. 'Cause I can only say it well once. I was wondering if Jacob said it that way to make sure that we all knew what country you were talking about, or if that's how you lived there as a kid, like.
Yeah, I wouldn't try and pronounce it really. I was like around Americans mostly. so
Sure.
it's-
No, that makes sense. Yeah.
Yeah.
How about you pronounce it for us?
Papa.
Qatar. See, I don't think I said it that well. I said more like cutter.
You did it really well. We looked at
Yeah,
each other,
we're like, wow.
Is that right?
Thank you. Duolingo has taught me something,
Yeah.
just not enough. Okay, so a quick poll. How many of your classmates do you think have submitted their compound for their analysis of an organic compound assignment? 4, 2, 5,
0.
none, 5, 5. By the way, this class has, I think, 22 people registered in it. So, and it's been 2 days since you learned about this. So, we're ranging from 0, 2 to 5. And the year is going up to 10. She's really expecting a lot from you guys. And I'll tell you something, the year I didn't submit yet, so she's holding you guys pretty high. It's been 3 of you guys have submitted, and I think that's a good start. And it took me about 40 seconds to approve all 3 of them, cumulative. And then it took me 3 minutes doing this to go in and erase the grade book. Because I don't know if you guys noticed, but I didn't change the due dates in time, and so it told you all that you had 0s on the bonus assignments, 0s on the homework, 0s on the final exam. You guys really missed the ball on that one.
It's just a little bit triggering.
Yeah, I can imagine. It's day 2, and you've got a 0 in the class. Congratulations. Did I spam you guys with that?
If you had Canvas email notifications on,
I apologize.
about 50.
There was no other way for me to do it. I tried. But I didn't want you sitting there thinking you had a different grade in the class all semester long. So better now than later. Yeah. one thing I want to say is I love that assignment, the analysis assignment, and I really do not want you to feel bad in any way if I give you a 0 and ask you to try again on any of them all semester. I look forward to those submissions. So the more you submit, the more I have to look forward to. Okay, I want to take a second to draw your attention to an event that is happening next week. I just can't draw your attention to it because I typed it in wrong. Oh, well, now I just don't know what I did wrong. The American Chemical Society Club, the ACS Club, which is confusingly not actually a registered club at SLIC, but more a community of clubs, is hosting a pizza and posters event September 2nd. That is Tuesday, the day after Labor Day, from 11 a.m. to 2 p.m. Now, I know a lot of you can't make it to that. That's why I'm not offering extra credit to go to this. Instead, I give you guys extra credit for things that you can do in class or outside of class, equal opportunity. However, if you are looking for something to put on your resume, if you are looking for volunteer opportunities or extracurricular opportunities, this is a great opportunity for you guys to get connected and find resources for them. So we're meeting in the same center, which is in the Student Center. There will be a guest speaker from 11 to noon, and then from noon to 2 p.m. is poster presentations from all of our student-led research projects. Is anybody hosting a poster? Kayla, Luis, not at Uprock, no, next week. Killian, will you be there?
I'll probably be there.
He'll probably be there. And he has been on a project with Raj.
Mm-hmm.
And so you probably have a poster that you can stand next to and try to recruit people for. Okay. Not all of you need extracurricular opportunities, but those of you who do, this is a unique extracurricular opportunity for a community college. Very few community colleges actively have undergraduate research, although it is a growing movement across the nation. And SLIC has been one of the pioneers in undergraduate research. Specifically, the chemistry department has been a pioneer in community college undergraduate research. And I know you all are in OChem too, but this is not limited to anyone in specific. Last fall, I took on some research students. I'm not the head lead for any project this fall, but last fall I took on some students who weren't even planning for general chemistry yet. So we take all students, all interests. It's just an opportunity for you to get connected. So put it in your calendar. If you'd like to make it, you do have to actually stick around to get the pizza. You can't just show up and then head out. Any questions on that?
Do you know the guy?
No, never met him. I also want to address that we have, within our chemistry department, 5 or 6 different student clubs that you are more than welcome to get involved with. Pre-Medical Professionals Club, anybody here a part of that? And you are the co-president of it? No, UPRA, or URC. I'll talk about that one then. Courtney, you are? Who else?
I'm a social media officer of the pre-medical.
Awesome. Who else was a part of PMP? I thought I saw another hand. Abram, you've gone? Oh, you're on campus groups? Right. We have the Pharmacy in Learning Society called PILS, sometimes just called Pre-Pharm. Anybody here a part of our PILS club? Those of you that want to learn about pharmacy school, PILS puts on programs throughout the semester where we have professors and graduate students and like academic advisors come down from the pharmacy schools, and they have trips that go up to the pharmacy schools for tours. So even if you don't want to be involved with them, it's a good resource to learn more about how to get into pharmacy school. We have the Slick Chemistry Club. Anybody here a registered part of the Slick Chemistry Club? Killian? Me? I am the official club advisor for Slick Chemistry Club. We also have the ACS Nano Club. Anybody here part of the ACS Nano? Yeah, I haven't had any of the ACS Nano in my OChem classes yet. That might change someday. And we have the Pre-Dental Club. Anybody here a part of the Pre-Dental Club? I know we have some people that are planning for dental school, and I will say our Pre-Dental Club is tiny, and it could benefit from more involvement with students. I think there's a similar opportunity to what pharmacy does, where we recruit people to talk about how to get into dental school, what that process is like, but it needs people to take that initiative to make those plans. So again, if you're looking for something to put on your resume, if you're looking for extracurriculars that really boost yourself on an application, that's a good opportunity for you. And then lastly, we have the Undergraduate Research Coalition Club. Kayla is a president, co-president. And do you want to tell us more about, that's not directly affiliated with the chemistry department, but it is kind of under the umbrella of our American Chemical Society clubs. Do you want to tell us more about what you guys organize?
Yeah, our mission is about helping students, especially first-gen and low-income students, just exposing them to research projects or helping them start their own. But we're also, one of our values is really community engagement. So we like having fun events. I don't know if you guys heard about the Star Party or came to that this summer. We partnered with the Clark Planetarium, and they brought 4 telescopes and guided us through some stargazing. We want to have a Science is Magic prom this year. We do a candle making event around Valentine's Day. So yeah, you don't have to be a part of the club to come to these events. We also are hosting a study and snacks session Thursdays 2:30 to 3:30 in the ACS room. So if you want to just come study and have some snacks, you're welcome to join.
I'm going to put that on the board. What did you say? Study and snacks Thursday.
2:30 to 3:30 in 190 or 290. And we also meet Wednesdays 11 to 12 at Trio in the Student Center. And we picked that time because Trio will often have lunches or snacks or goodies left over. So you like food.
The chemistry department has a space on the second floor of the SI building. You can see it from here. Well, you guys don't know what you're looking at, but technically it's one of those windows. SI 290. We call it the ACS room, the American Chemical Society room. And it's a little confusing. There is no recognized club on campus called ACS, but we have kind of leadership that governs all of those other clubs I was mentioning. This is not for any registered member. It's not for anyone who's registered as a part of a club. It's for all of you. It is a study space. It's also a meeting space. But you guys are always welcome to stop in, build connections, do your homework, whatever you want to do. All right. So, are we ready to move into some chemistry? Have you guys been itching for this? You waiting? Ready? Yeah. I just want to make it clear that our first unit, Unit 1, is OChem 1 review. Because I taught a lot of you, but not all of you. And even the ones that I did teach, oh, I've got your I've got your final exams back. Oh, actually, some of you from the spring, I forgot to grab yours. I didn't look through them. It was my summer students that reminded me. So next week, spring students, if you don't have your final exams, send me a message on Tuesday to remind me to bring yours, and I will hand back your final exams. It's kind of weird handing back exams on the first day. So I want to make sure that we're on the same page. Now you can get this final exam. Oh, I didn't upload it yet. I'll try to do that right now. You can get this final exam and you can test yourself on it because I'm going to have it uploaded to Canvas. It's going to be a good way for you to practice for our final exam, but Sorry. This is, I'm all over the place. I'm still sick. I'm going to blame it on that. I will upload my OChem 1 midterm and final exam from the summer, the ones that these people just dropped out. So that if you're curious, coming into my class for the first time, what I expected from OChem 1, you can look at that OChem 1 exam and see what it was like. I will also have my OChem 2 final exam and midterm that you will use to study for this semester. Okay. So we're going to breeze through some important background and some important terms. I talked to you guys the other day about the fundamental forces, but we didn't quite define where chemistry falls in line with that. Chemistry is the study of matter and its interactions. Organic chemistry studies the branch of matter that involves carbon-based molecules. Actually, hydrocarbon-based molecules. For instance, your typical alkane has a generic chemical formula, CnH2n plus 2. There are some interesting things that have carbon and hydrogen that may or may not be organic. So, some of you may recognize this chemical. Anybody know this name? It's not carbonate.
Carbonic acid.
It's carbonic acid. Is carbonic acid organic or inorganic?
Inorganic.
Is it a hydrocarbon molecule or is it not a hydrocarbon molecule? I should say, is it a hydrocarbon or hydrocarbon derivative? Well, let's look at its bond line structure. It has hydrogen and it has carbon, but there are no hydrogens bonded to carbon. But not all compounds that are considered organic need to have hydrogen to carbon bonds. For instance, you guys may know of those forever chemicals, PFOs. Those are often carboxylic acid compounds that have fluorine bonds coming off of every position at the carbons. And they're called PFOs because they are polyfluoro acids. Maybe they're called PFAs. Yeah, thank you. Polyfluoro acids. No hydrogens bonded to carbons, very much considered an organic molecule. So I want to talk to you guys about carbonic acid. Organic or inorganic? Organic, because this is organic, feels like that should be organic. I'll give you another one, CO2. This is a fairly good consensus that says this is inorganic. But the difference between CO2 and H2CO3 is an equivalence of water, and water is very much inorganic. So it feels a bit odd to say that this is inorganic and this is organic. And actually, carbonic acid readily decomposes into CO2 and H2O. This is that fizzing that you hear when you open up a soda can. That carbonic acid is breaking up into CO2 and H2O, and that pressurized CO2 is bubbling out. So it's an interesting branch. I will say this, we as humans love our little boxes. And we just try to make boxes that fit around everything. Nature doesn't give an F about our boxes. It doesn't care what we want to call something. It's just going to exist. So call this organic, call this inorganic, call this organic, nature doesn't care. All of these compounds exist. And they all have predictable chemistry. CF bonds, very strong, very hard to break. So PFAs, they're not prone to degrade. They stick around forever. We're going to be studying everything that has these carbons, and we're going to look at what to understand about their chemistry. But generally, it's all going to be classified as organic chemistry. Okay. We talked about the fun. Oh, yes.
So organic chemistry is just the similar characteristics of carbon compounds, carbon chains?
Not necessarily carbon chains. A lot of organic molecules have carbon chains, but methane is one of the most abundant organic compounds, I think.
So just carbon compounds?
Hydrocarbon.
Hydrocarbon?
Hydrocarbon compounds. Yep.
And
they're derivatives. So that's where you introduce heteroatoms, like oxygen, nitrogen, halogens, sulfur, phosphorus, and you get all your functional groups. An amino acid is a hydrocarbon derivative, for instance.
So we'll figure out what organic means by just experiencing what the traits of carbon compounds are?
You'll know what organic means by knowing that it has carbon in it, usually. Diamond is not organic. Charcoal is not organic, even though they are carbon. So it needs to be a hydrocarbon derivative. That's the box we decided. Yeah? Okay. So we talked about the fundamental forces, and we said one of them, the most important one that governs chemistry, is the electromagnetic force. And we said, in part, that there's this attraction between positively charged particles and negatively charged particles. So we said that the atom, which is the building block of all of our chemistry, has this nucleus, which has all of the protons and neutrons packed into it. So the nucleus has all of the weight. It is net positive. How big is the nucleus compared to the atom? Tiny. The other part of the atom is what? Yeah, our electron cloud. This has none of the weight, essentially. This is net negative, because all those electrons are being pulled by the electromagnetic force towards the positively charged nucleus. This has all of the sides. When you talk about an atom, you are generally talking about its electron cloud. When you talk about how big an atom is, you're talking about its electron cloud. Now that electromagnetic force, it's not just as simple as electron gets pulled towards positively charged nucleus, and then they just go in a circle, right? You guys know that these orbitals are quite complicated. Some of you have had me before, and so you know that I want to think about orbitals in a very specific way. First, maybe someone who hasn't had me before, how do you think of orbitals? What are electron orbitals?
Space different energies of electrons occupy.
The space that different energy of electrons occupy. The space that electrons occupy, and different electrons with different energies occupy different spaces. Or maybe they overlap some space, but they have unique space in all. I like that. And I don't think it's wrong. Now, those of you who have had me before, what's the clarifying portion that I would add into that definition of an electron orbital? It's not just the space that electrons with different energies occupy. There's something that I would put in the front of it. Anybody remember?
It's where they're most likely to be.
It's true that an electron orbital is considered 95% of the probability region. But there's another part that I'd like to clarify in there. And it has to do with clarifying the term space. Not size necessarily, although that's a good clarifier. Shape. Not necessarily shape either, but that's a good clarifier.
Is that the orbitals made up of the electron being effectively everywhere there?
We'll get to that. It is that the shape is defined by a mathematical equation. So an electron orbital is a math function. Electron orbitals. It's a mathematical equation that describes the shape, the size, and the orientation of where an electron is. So when I draw you an image of an electron orbital, I don't want you to think, kind of like what Killian said, I don't want you to think this is where the electron is roaming around. That is where the electron is. Electrons are waves. This is its shape, its size, and its orientation. If I tell you that an electron orbital is oriented at you, that's different than an electron orbital being oriented straight up and down, which is different than an electron orbital being oriented left to right. That comes with these shapes and sizes that have specific directional geometry. It doesn't come when they have spherical geometry. At that point, a sphere points in all directions. So this is important. And that mathematical equation is cut off at 95% of the mathematical equation, the probability density of where the electron is, because that mathematical equation has like an asymptote that goes to 0. It never is 0. So some of you might have heard me say before that there is a non-zero chance that all of your electrons at some point spontaneously exist on the moon before spontaneously coming back. It's non-zero, it's not likely, but it's non-zero. Because electrons are waves, electrons do not have to exist in a specific spot. Electrons don't travel the way that you and I do. I've been pacing back and forth. Electrons can just be back and forth without having to go through the middle. So let's talk about these electrons a little bit, shall we? Or do you guys want to come back to the electron clouds? Do you want to come back to the orbitals? Let's actually keep building. We are here now, but I want us to get some more terminology down first, I think. Let's move on from the atom and what it's made up of. Let's compare and contrast an atom versus an ion. Did you guys know, do you know where atoms are made? Sorry? Our atoms were not made in our sun. But our sun and our atoms were probably both made from the core of a dead star. So stars make atoms. Hydrogen gets fused into helium. Helium gets fused into lithium. Lithium to carbon. Carbon to oxygen. Oxygen to silicon. Silicon to iron, I think. It's a weird process. It doesn't really make sense. And then those really big stars, they go supernova, they explode. And in that explosion, they fuse some of the really heavy atoms and they make those rare earth elements. You get your really heavy elements, the super low abundance. Iron is usually that last stage before explosion, which is why we have a lot of iron, but it's in the core. We have a ton of carbon, and that's because carbon is made for a much longer amount of time. So, what's the difference between these atoms that are being made in the stars and then find their way here to us on Earth and ions? Should be pretty easy. Charge. Atoms are neutral. That means the number of protons is equal to the number of electrons. And the number of protons tells us what?
The element it is.
The element. The number of electrons doesn't matter. An ion is charged. That means the number of protons does not equal the number of electrons. And for any specific element's atom, you cannot create an ion by changing the number of protons, because that would change the element itself. So you change the number of electrons to change the element itself. So would you guys do me a favor? Turn to a neighbor or several neighbors next to you. I want you to come up with your 2 favorite ions. Maybe you don't have a favorite. Think of the 2 ions that come to mind.
Good to see you again. Probably hydrogen. Isn't that acid? Or, yeah. Do we all have to decide on 2? The 2 best ones?
Okay, ready? List them off. What do you got?
Sodium.
Sodium ion.
Yeah.
So, Na+. Okay. Potassium ion. K+. Calcium ion. Ca2+. Hydroxide ion. HO-. Magnesium ion. Mg2+. You guys went with the easiest ones. Hydrogen ion. H+. Also known as a proton. I don't know if this bugs you, but that bugs me. That the hydrogen ion is the subatomic particle, the proton. It really, gives me shivers. I have a therapist for that. I don't, but if you know a therapist that can talk to me about that, let me know.
Iron ion.
Iron, which one? Okay. Now, I will say, a lot of these that we've talked about, they're not going to be super common to us, but the iron ion, probably the least, unfortunately. I put both of them, because let's remember ferrous and ferric, right? I don't wonder if you guys could actually figure out which one is ferrous and which one is ferric. We don't talk about that a lot. In general chemistry, we call it iron 2 in Roman numerals and iron 3 in Roman numerals. But you do learn about sulfurous and sulfuric. What's the difference?
Sulfuric is 2 H's.
Sulfuric and sulfurous acids are both 2 H's. It's the number of oxygens. And the number of oxygens leads to the oxidation state being different. So sulfurous and sulfuric, they tell us oxidation state of sulfur. Ferrous and ferric tell us the oxidation state of iron. Sulfurous acid is H2SO3. Sulfuric acid is the one you're most familiar with, H2SO4. Which one is more oxidized? Which one is more positive? Sulfuric or sulfurous? H2SO3 or H2SO4?
I'd say SO3.
You think the one with less oxygens is more oxidized? I'm just going to write this out for you.
Is more positive?
Okay, well, I'll say this. Oxidation is loss of electrons.
Yeah, more positive.
It's named oxidation because oxygen takes the electrons and leaves a more positive charge on the other atom. So which of them do you think is more oxidized? SO4. So which one do you think has a more positive oxidation state?
I still think it's SO3.
Sorry, oxidation is loss of electrons. What do you get if you lose electrons? Positive. So more oxidized should be more positive. This is more oxidized. This sulfur has a more positive oxidation state. We can prove it if we look at the Lewis dot structures for our sulfur atom there. I'm assuming a lone pair of electrons on that top sulfur. I know it looks weird. Sulfur can expand its octet. This has 2 additional bonds to oxygen relative to this. So this is more oxidized, has a more positive oxidation state because it's losing more of its electrons to oxygen. Sulfuric, sulfurous. Let's apply that here. Which one is ferric? Which one is ferrous? 3 plus is ick, 2 plus is us. More oxidized gets ick, less oxidized gets us. So this is ferrous, iron 2. This is ferric, iron 3 plus. Do you know what we just had an exercise in? Nomenclature, a system of naming. How we take a suffix and use it to tell us something about the compound. We didn't actually have this conversation, but we had some nomenclature in here as well. Tell me what's similar about these names. Sodium, potassium, calcium, magnesium, and hydronium. What do they all have in common? Same suffix, ium. So what does ium tell us in nomenclature? No, because this is not an element. None of these are actually elements, but I will say these share their elemental name. They're positively charged. Doesn't necessarily say how many positive charges, but that suffix ium is an indicator that something takes on a positive charge. And maybe that's confusing because elemental calcium is neutral, but calcium is named with an ium to indicate a positive charge because it's most often found in its salt form. It's most often interacted with by humans in its cationic form. Same with sodium, same with lithium. Hydronium is different, right? Because hydronium is confusing where we call H3O plus hydronium as well. And that's not an elemental name for anything. Okay, do we have more that we want to add on here? Chloride. What else? Nitrate. I like that. NO3 minus. Nitride. N3 minus. Is that what you wanted?
I said nitrite.
Oh, nitrite. Yeah. NO2 minus. No, well, that's a little bit better. That's another lesson in nomenclature, ate versus ite. indicating oxidation state. Which one is more oxidized, 8 or 8? 8 is more oxidized over 8. And there's a connection between nitrate making nitric acid and nitrite making nitrous acid because the oxidation states are related. Others that you guys want to put up here? Cyanide. Cn minus. Anything else? Bicarbonate. Okay. HCO3 minus.
Permanganate?
Permanganate. You're going to really test me on this one. Thank you. Manganate. Permanganate. You said manganate or permanganate?
There's a difference?
Per is part of the nomenclature. Per says more, like peroxide has more oxygen. So permanganate. Manganate would be MnO3 minus. Permanganate is an additional oxygen.
Okay.
Manganite would be MnO2, and hypomanganite would be MnO minus. I've never heard of any of the others, to be quite honest. Permanganate is the one that I hear of the most.
So does the 8 mean that there's an oxygen with it?
So 8 and 8 both indicate oxygens.
Okay.
But they indicate a different number of oxygens. 8 indicates more oxygens than 8, but not necessarily a specific number of oxygens. This is nitrate, and this is permanganate. Yeah, it's a little confusing there, but... All right, I'm going to cut it there. I want you guys to tell me something about this list. There's one exception on this list that I think you could argue about, but pretty much this whole list has something in common. I want you guys to think about what that is while we take our 5-minute break. So why don't you guys get up, move around, get your blood flowing, and when we come back in, I want to point out what all of these have in common with each other about being ions, with the exception that you could maybe argue about one. Okay? 5 minutes. And don't give me something like they exist.
Is it significant to say they form ionic bonds?
I guess I could have clarified. They create a specific class of ions. We can separate them from a different class of ions.
They're a different type. Oh. Polyatomic ions?
No, not all of those are polyatomic.
Well, so you're allergic to bananas?
No, I just throw up when I smell them or eat them. One day I ate 7 bananas as a kid.
Mm-hmm.
And then I threw up.
Oh, and just
and now I throw up when I smell bananas.
Eat a lot of Sprite as a kid? Or drink a lot of Sprite?
Only when I was sick. I don't throw up when I drink Sprite.
Well.
Oh. No. No, it's just the bananas. Just ate too many bananas.
We only have 5 minutes?
You're welcome.
Well, I mean, hey, this is the bureaucrats. They say, John, give your students more time.
No.
Are you sure?
Oh, absolutely not.
My math professor said that you have to get like a quarter of the class or something as every hour is like a certain amount of minutes in math. Caesar, you don't know.
My Calc 2 professor only gives 2 minutes.
Can't do anything in 2 minutes.
I know.
I say 5 minutes so that I can give you 10. When I say 10 minutes, I give you 15. It's not good. There is something to be said about how much time I should be actually speaking in class. I speak too much. I need to give you guys more time to actually solve problems on your own.
Well,
that's something I'm always working towards.
Who told you that?
All of the education courses I've taken.
What do they know? They're just professionals in the field that you're working in.
Right. Yeah.
I'll be to my car. I need your opinion on this.
Oh, I need to.
standard texture.
I used to love it. Yeah, the texture is really rough for me now too.
Like
But
like 2 or 3 bites in.
I can't even have a smoothie.
Really?
No,
I
it's
could do
like
smoothies.
the taste of it in the smoothie is rough.
I could do smoothies. I just can't eat just like.
Yeah, I get it. That texture is weird. Has it always been that way?
Yeah.
It wasn't that way for me forever. I remember that day vividly. I loved bananas, and then I threw up.
Yeah, that's fair.
I'm excited to come back in next week with no mask. This really sucks. My ears hurt so bad. My glasses keep fogging. I can't hear myself, so I feel like I'm screaming. Can you guys even hear me?
Yeah, you're doing good.
Okay, great.
Screaming is working.
Great.
Keep screaming.
Seems whatever that stuff you put on your glasses is helping out.
It's helping more than Tuesday for sure, but it's still like a almost underwater view, you know.
It's suffocates.
Yeah,
For airplanes.
and that's an N95 probably would have been safer, right? Because it creates a better seal.
You can't breathe in that.
Yeah,
You're fine.
that's what I'm hoping. Yeah, yeah, yeah.
And 95 is really good exposure. I love that.
Good. You know, I actually didn't buy these. When we moved into our house last summer, there was a box of K95s, and I've never had to use them. But I was like, boy, where am I going to get a mask the first day of classes? And I looked in my closet and had one there.
You're never gonna guess where I found this.
I'm never going to guess what it is.
Yeah, well, that's my question. So, some metal, it's heavy, but I think it's pretty cool. But I was wondering, how can I figure out what it is?
Well, you could scrape some of it off and do some chemical tests with it.
Oh,
Like what will oxidize it, what will, so if you can oxidize it, you can get it into a salt solution. If you can get it into a salt solution, then you can try to precipitate it. So you can basically use its redox potential and solubility properties to try and identify what it is. Or you could get it, if you can oxidize it, you can take, if it has a color.
Standards for that? Solubility potential?
Not solubility potential, no, reduction potential. There are standards for it.
Should I know that?
There's a table.
Okay. Do
So-
we test it before in the lab or something? Or?
OCHEM 2 lab?
Oh, so we will do it.
I'm sorry, Gen Chem 2 lab.
Okay.
Yeah, you did reduction potentials in Gen Chem 2. Twice. 2 different ways.
The last two ones? Or besides that?
I don't remember how late they were.
It was pretty close to the end.
They were the second to last two.
You remember the battery?
Yeah, with like the spider looking thing?
Yes.
You cut
Yep.
paper? Oh, okay. Yeah, I remember that.
But you would need to get it into a salt first. So
How do I just
if you mix it with nitric acid and it oxidizes, that might be a clue. And if also it oxidizes with HCl and sulfuric acid, that might be a clue. Because certain metals will oxidize with all or selective. So you could try to rule it down to a few that way, and then look at its precipitation solubility properties.
You think it looks like copper?
I thought it looked like copper too, but it could be an alloy, right?
Well, how are mixes checked?
I don't know.
wonder if Raj ever had to find out identity of random.
I bet he could help you though, for sure. Oh shit. All right, what do you guys think? I got stuck on this. What do these all have in common with each other that sets them apart from a different class of ions? With the arguable exception of one of them.
Oh, there's only. Is it the?
No, the exception is not the proton.
Isn't that there's only
Keep trying.
one ion per molecule?
Do you guys want me to tell you what the arguable exception is? Oh yeah, you know, you because of the conversation we actually had, I think you could actually make that argument. You could argue that these two could be in the other class. The others are all distinguished from another class of ionic compounds we could look at. Okay, that's true. They are the only ones with carbon in them. So what could you call this class of compounds then? Inorganic ions. They're all ionic, right? Right? But these are ions that don't have organic properties. They are not hydrocarbon based. So, inorganic ions. Now I want you to turn to your neighbor. You can't use cyanide or bicarbonate, which arguably may not be hydrocarbon based. Cyanide doesn't have a hydrogen. Bicarb doesn't have a carbon-hydrogen bond, so we kind of discussed earlier about how carbonate is not really well defined. I want you to turn with your group again and try to come up with an organic ion that we can put onto the board. Go ahead.
There are some?
There's so many. I mean, like an infinite number of theoretical.
Oh, should know this.
Just come up with generic, you know? We'll name it. If you can't put a specific name to it, describe it. Okay, can I hear some?
Yeah. An ethyl group attached to oxygen.
So we could write that a couple of different ways. We could put ETO minus. ET is saying ethyl. We could also spell it out as a condensed molecular formula. CH3CH2O minus. What else could we do? A little zigzag with O minus. That is called eth oxide. Because if you think about it, it's oxide, O2 minus, but it's bonded to an ethyl group, 2 carbon chains, so it's ethoxide, just 1 minus. These are called alkoxides because they are carbon chains bonded to a negatively charged oxygen. ALK is that nomenclature that describes carbon chain.
So where does when we're talking about a charged molecule or a molecule that has a charge, where does that end and an ion begin, or vice versa?
What do you think?
Well,
where does a molecule end and an ion start?
Well, if you're looking at a charged particle, then I've got carbocations on the mind from Pokemon 1, so it's like technically that has a charge, technically that is ionic, but it's not as ionic as what we're looking at here.
Wait, say it one more time for me again. You've got what on the mind?
Carbocations?
Carbocations. I would say those are just as ionic. They've got a charge. So there are 3 types of ions: cations, anions, and Zwitter ions. Anybody know the definition of Zwitter ion? It's a weird name. Zwitter ions are neutral. They have no net charge. But they have both positive and negative charges. One of your most common examples in biology would be most amino acids. Amines are good bases and carboxylic acids are good acids. And so at neutral pH, you often have a protonated amine and a deprotonated carboxylic acid. I may be wrong there in saying at neutral pH, but maybe more at anatomical pH. I don't know. I'm not a biologist. Anyways, you can make this happen. That's a neutral compound that has both a cation and an anion. How many of you are taking OChem 2 lab this semester? Cool. In your first experiment, you will be synthesizing methyl orange, which is a pH dye indicator. One of the forms of methyl orange, it's conjugate acid, it's conjugate base. One form is a Zwitter ion. One form is just an anion. So you'll be hearing that term a little bit more in your lab course. Does that answer your... No, I don't think it answers your question, Russ. The idea is, no matter how large a molecule is, if there is a charge on it, it's now an ionic compound, regardless of how long the covalent component is. This has just 2 atoms with 1 covalent bond. That's ionic. This has 5 atoms with 3 sigma bonds and 1 pi bond, give or take. That's ionic. So here we've got a lot more sigma bonds, but it's still got a charge. So it's still ionic. Does that answer your question? Mm-hmm. We can go from monoatomic to diatomic to polyatomic, and they can all be ionic. Cool. I want to hear some other organic ions. Acetate. This is a good one. Now, a few other ways to write it. ACO minus, CH3, CO2 minus, and of course, its bond line form, a methyl group connected to the conjugate base of a carboxylic acid. Yes, oxalate would be an organic compound. I don't know the abbreviation for oxalate, but I bet there is one. So instead, I'm going to give you the condensed molecular formula and its bond line structure. Condensed molecular formula would probably be written like this. I know that looks a little odd. The other way that you could write its condensed molecular formula is CO2 2 minus. I don't think that looks better. Actually, its bond line structure, I think, gives the most information. That's your oxalate ion. And that, despite not having any carbon-hydrogen bonds, almost no one would argue that that is not a hydrocarbon derivative. That's a hydrocarbon derivative. And it's ionic. So it's an organic ion. Others? Tert butoxide. All right, I'm going to leave that one up here with the other alkoxides. But tert butoxide was really important for us at the end of OChem 1. And it will be important for us in this semester as well. It will come back. Russ gave us one before. You want to commit to it?
If I remember what it was. What did I say?
Your carbocation.
Oh, yeah.
So carbocations, in general, there's a lot of different ways to write them. Let's talk about the tert-butyl cation. So that's going to be your 3 methyl groups and a positive charge. not incredibly stable. I don't think that you can buy a bottle of tert-butyl cation. I don't think you can buy a bottle with any cation. So some other cations that are organic that you can use. I don't think a lot of you would have seen this in your OChem 1 class. This is pyridinium. Pyridinium is organic. Pyridinium has a nitrogen bonded to hydrogen, 3 bonds to carbon, 4 bonds to nitrogen, gives it a positive charge. So overall, +1. Can we think of any others? You all talked with each other, right? So were you just scratching your heads? Do you feel like now it makes sense what I was trying to get out of you? To look at all of those ions we looked at over the semester? We can call those acetylide ions. I'm going to abbreviate this one. Is that what you're looking for? That carbon that holds the negative charge at the end. Good. That's a nucleophile. We can use that. Well, a lot of these things are nucleophiles, but this is most useful as a nucleophile in synthesis. We can use it to bond to another carbon and create a much longer carbon chain. So these are the organic ions.
What does TS stand for?
TS, that's a good one. So you want to look, since we're on the topic of organic compounds, let's look at, ionic compounds. Let's look at TSO minus. Tosylate. Tosylate is kind of a common name based on an accepted common name. When you have that 6-membered aromatic ring with a methyl group, we call that toluene. And when you have an SO3H group attached to toluene, you can call that sulfonyl group tosyl. When it's combined with toluene, tosyl, combines sulfonyl and toluene. But this is 8, indicating that we've got an anion. This is not just a tosyl molecule, but it's tosylate. Does that answer your question? Well, that's too bad.
I just wanted the name.
Tosyl. Or toluene sulfonyl. Sulfonyl toluene. Earlier we were talking about atoms, and then ions, and then pretty quickly we had more than just one atom. We started looking at a lot of different atoms. So, can you guys help me distinguish these two terms? Molecule and compound. I want you to work together with your neighbors. Can you come up with an example that distinguishes the difference between molecule and compound, that highlights what each of them are trying to say? Just take 2 minutes on this. See if you can come up with examples of molecule and compound that compare and contrast what those words are saying.
Easy contrast for that. Chloride. And that's a
compound is a combination of molecules. So like you can't just have a compound unless you have molecules that can like build them up.
Yeah.
Or maybe you've just got examples. Maybe you can distinguish what they are, and we have to figure out what the distinction is. Definitely. Like a molecule is not a precursor to it. Totally. Think about the word we're using there, compound. What'd you come up with? What examples did you think of for molecule? Oxygen? O2. What else did you think of for molecule? Tell me. Hydrogen gas, H2. What else did you come up with?
H2O.
H2O is a molecule. What else did you come up with? So do you mean hydroxide, OH minus, or do you mean ROH, alcohol?
ROH.
So let's say methanol, CH3OH, molecule. Okay, I agree with all of these. Anything else you want to add? Not all of them are compounds. Give me your compounds.
Sodium chloride.
Sodium chloride. Keep going.
Ammonia.
Ammonia, NH3. Keep going. Carbonate can be a compound for sure. CO3, 2 minus. It's not about ionic bonds. I think I heard that. Because ammonia doesn't have ionic bonds. Good. That's it. So, you want to say it louder, Bryce? A compound is different from a molecule in that
It uses 2 elements.
it needs more than one element. So, H2O and CH3OH are molecules because they consist of more than one atom. H2O and CH3OH are also compounds because they consist of more than one element. What we're looking at in our examples here is the distinction between let's use a better word, covalent compounds and ionic compounds. O2 is not a compound, but it's not an atom, it's diatomic. O2 is a molecule. It exists because there's more than one atom, despite those atoms being the same element, so they cannot be a compound. So on this list, we have organic and inorganic molecules. Methanol is an organic molecule. Water, hydrogen, oxygen, inorganic molecules. So I want you guys to know what these terms are because we are going to use them a lot. And I want you to be reminded about the distinction between what is organic and what is inorganic. This list of our compounds could be a little bit better, but remember, methanol is an organic compound. Carbonate, maybe you could consider is an organic ionic compound. Some people might argue it's not an organic ionic compound, that it's inorganic. But that's just because it's hard to know why we put the boundaries where we did.
But if you can make carbonate from methane, then doesn't that squash it?
You can derive CO2 from methane. but most people would say CO2 is inorganic. So I think that some of those molecules, they highlight why it's challenging that we put the boundaries where we did. Yeah? We have to be comfortable with nature not agreeing with our boundaries. Are you comfortable with that? Cool, me too. All right. We've got some other general ideas to cover still. So let's talk about what's going on within those molecules. Let's look at covalent and ionic bonds. Can you describe the difference between a covalent and an ionic bond? Sharing versus taking. I forgot my magnets again today. I told my partner I forgot my magnets, and he was like, "Oh, thank God, no one's touching our little." They hold our window curtains in place. I don't care that they're so fun.
That ruins those scraps of magnets. I thought it was like some fancy scientific.
Oh, I thought I told you. No, they're just window curtain holders. Maybe I just need to buy a pair and keep them in my office. So remember that all of the things we're looking at, these are all different types of magnets. Some are weak, some are strong. Very weak, very weak. They don't interact with other magnets pretty much at all. Pretty strong, fairly strong, very strong, depending on what other magnet you've got next to it.
Stronger?
Strong magnets, they pull onto each other tightly. Hard to pull them apart. So,
is the strongest F2?
No, F2 would be a pretty weak magnet because it's diatomic, non-polar. Really, the idea there is polarity in terms of calling a molecule a strong or weak magnet and charge. Ions have that strong magnet pull towards other ions. Additionally, a strong magnetic repulsion from ions of similar charge. So when we look at covalent bonds, these are shared electrons between atoms. Each atom is pulling on the electron, sometimes more strongly. So we get nonpolar bonds when the difference in electronegativity is less than 0.4. That's a boundary that we set. I don't like that boundary, and I'm going to tell you why. The CH bond has a difference in electronegativity of 0.4. I suppose I need to say less than or equal to 0.4 for this definition. That means that the CH bond is nonpolar. That's what we call it. And we're calling it that because the CH bond acts like a weak magnet. That's all. It doesn't create strong interactions with other magnets. But is the difference in electronegativity 0? No. So we can still predict how that magnet will behave. This part of the magnet is more positive, and this part of the magnet is more negative. If the electrons are going to be taken when the bond breaks, who takes them? Carbon. Despite the fact that we say neither of the atoms owns the electrons. We call it nonpolar, but it has a dipole. I don't like that. You very well may see a question, especially if you look back at your OChem 1 exams with me. You'll notice that I have a question that says, which of these bonds is considered nonpolar? not which of these bonds has no dipole, because those are two different things. I'm not happy about it, but I'm just me. And then we've got polar bonds, polar covalent bonds. This is when the difference in electronegativity is greater than 0.4, but less than or equal to 1.0. A difference in electronegativity greater than 1, you get ionic bonds. Can you give me an example of a polar covalent bond? Let's keep it to organic compounds. So instead of water, let's just pick a bond, not a molecule. Bonds that you will see frequently in organic compounds. Carbon-oxygen bond. Single bond or double bond?
Double.
Okay, both actually. Let's put both. I was hoping you would say either.
Oh.
Give me more. Single bond, double bond, or triple bond? All of the above. Good answer. Give me more. Bonds that you frequently see in organic chemistry, in organic molecules. Carbon-halogen bonds. And I will admit, not all carbon-halogen bonds actually have a difference of electronegativity that falls in that range. Carbon and iodine have the exact same electronegative value. But you can still predict which way the magnet goes. It always goes to, the negative always goes to the halogen. It has something to do with the size after you get to a certain point. Give me more. Get away from carbon.
What?
OH. Very common bond in organic molecules. Give me more. Sorry? We're looking for bonds. So I think you're looking for NH. That is a common bond in organic molecules. Anything else?
Boron carbon?
We won't see boron carbon, but we have worked with boron to hydrogen. That's not going to be in an organic molecule, but it can still help us understand the reactivity a little bit. All right, in this first row on the left, can you tell me which has the positive charge? Which atom, if the bond broke, would lose the electrons? Which one is partial positive?
Carbon.
Carbon on all of them. Oxygen is more electronegative. Nitrogen is more electronegative than carbon. Carbon to halogen, X. Which one gets the positive charge? Carbon. Oxygen to hydrogen, which one gets the positive charge? Hydrogen. If the OH bond broke, where do the electrons go? Back to oxygen. NH, positive goes hydrogen. BH, positive goes hydrogen. Raise your hand for hydrogen. Raise your hand for boron. We're split. Anybody want to give their rationale?
I think I'm remembering this wrong. Doesn't boron actually have less electronegativity?
Boron is less electronegative than hydrogen. But I did make a mistake. BH is not a polar bond. That was a mistake. So BH does not belong down here.
What is it?
BH has a difference in electronegativity of 0.1. That is a smaller difference in electronegativity than C to H, and yet textbooks will emphasize the partial charge character because it explains the chemistry. Boron is less electronegative. It gets a partial positive. Hydrogen is more electronegative. This is one of the few times hydrogen takes on a partial negative charge in a bond. But I made this mistake the BH bond is a nonpolar bond, despite having a dipole. What's the only time you really get zero difference in electronegativity? One element bonded to another atom of the same element. Good. All right, let's wrap this up with ionic bonds. You guys told me that the difference here was they're taken. You get charges. You've got a cation and an anion. I want to take an example, ionic compound, inorganic or organic. Can you guys give me one? NaCl. Is this an appropriate way to draw NaCl?
No.
Tell me why. We've agreed that that line means shared. This is wrong. It does not exist. Now, in the context of organic chemistry, you will be drawing arrow-pushing mechanisms. You will be in charge of showing how electrons move. And if you tell me that first there is a bond between Na and Cl, and then the electrons leave that bond, you will lose points. Why? Because that's not what happens. There is no bond there. And I worry about bringing this up because I've brought it up in the past, and I think I put the idea into people's heads that it can exist. So if you wanted to show the bond between them, what would you do? Yeah, I mean, you're really limited to just Na plus and Cl minus, or you could just say NaCl, and because you know it's a metal and a non-metal, you know that it's an ionic bond. There is no line between them. So hydrogen bonding is a specific instance. It's when a hydrogen that is bonded to a fluorine atom or an oxygen atom or a nitrogen atom is strongly interacting with the lone pair of a fluorine or oxygen or nitrogen. And you don't represent a hydrogen bond with a dotted line per se. It's just often visualized that way. A hydrogen bond is a bond or is not a bond?
Not a bond.
Is it a covalent bond? No, it's definitely not. It's about 10 times weaker than a covalent bond. So the energy required to break that magnetic attraction, much, much weaker than breaking the actual O to H bond itself, or F to H bond itself. Hydrogen bonding, in my opinion, is a terrible, terrible name, because it makes you think it's a bond. Or maybe we just have a bad definition of bond. And maybe we just should say everything is a type of interaction, and those interactions scale. Hydrogen bonds are on the low end of interactions. Ionic bonds are on the high end of interactions. And then there's this interesting solvation interaction where strong ionic bonds can be broken apart and replaced by several, like many, many, many dipole to ion interactions. So you can break very strong ionic bonds if you replace it with a plethora of dipole ion interactions. Russ?
Wasn't hydrogen bonding considered to be an intermolecular force?
It is. And covalent bonds and ionic bonds are considered covalent bonds are considered an intermolecular force. And intermolecular forces are much stronger than, covalent bonding is an intramolecular force, which is much stronger than an intermolecular force. Hydrogen bonding is intermolecular. Covalent bonding is intramolecular. Ionic bonding, well, you guys said it. Ionic compounds are not molecules, they're compounds. So, technically ionic bonds are can you say intermolecular if they're not molecules? Well, that's a molecule. Well, no, it's not. It's a compound. Boundaries, terms that we decided and nature doesn't really like to listen to. Go Bruins.
The dipole thing. The dipole thing, does it have to be made in solution and like dried out, or can you just like put a bunch of dipole molecules in with an ionic bond, ionic salt, and just like heat it up without putting it in solution?
Yeah.
And switch.
Have you ever taken salt and put it in water and watched the salt dissolve?
Mm-hmm.
You are replacing the ion-ion interactions within salt with dipole ion interactions between water and the ions. All right, we're just about at the end today. Before I let you leave, I want to take an example of terp butoxide. We often look at terp butoxide as a salt. Potassium terp butoxide is very commonly used, KO TBU. This compound has both ionic bonds and covalent bonds. You've got the ionic bond between K plus and O minus, and you've got the covalent bond between C to O, C to C, and C to H. We're going to dig in more into these covalent bonds. Covalent bonds come primarily in two flavors beyond their partial charge nature. The way that the orbitals overlap to give us the bonds. Do you guys remember the names we give to those? Sigma and pi. So when we come back, we're going to look more at hybridization and how it leads into sigma covalent bonds and pi covalent bonds. But I want to tell you guys before I let you leave today why I think they're called sigma and pi. I don't know that I was ever told this with certainty, but it makes a lot of sense if what I believe is true. A sigma bond consists of the overlap of orbitals head-on. We're going to talk more about those orbitals next week. If you were to put your perspective through that bond, this is a little eyeball. This is the way it's looking. What would it look like? I'll do a equals.
Are you inside the S bond?
I'm looking through it. I'm out here. I'm on the outside of it. I'm looking through it.
Is it hollow?
It's a mathematical equation. We could write a mathematical equation to describe the shape of this room, and then I want you to draw it from the perspective of standing outside, from that couple taking their pictures. Now, you might argue that these little nodes on the outside, when you look down it, that's going to give you some little something on the middle there. But for most of it, it's going to look like this. What does that look like? It looks like a circle. It would actually have some three-dimensionality to it. So what does that look like? A sphere. And it's still an orbital, so what orbital looks like a sphere? S orbital. If it looks like an S orbital down the bond, then we call it a sigma bond. I guess it makes more sense if I spell sigma. S orbital, S bond. Sorry, S orbital, sigma bond. Did I make sense when I said that? alliteration, right? If it looks like an s orbital, it's a sigma bond. Our pi bonds look like this. Side-to-side overlap, there must be constructive interference. The shading, we're going to talk about this more next week, just means does the mathematical equation start with a plus or does it start with a minus? And these equations can have both. You guys know the quadratic formula? Plus or minus the square root of, right? When you look down this, when you look through this bond, what does it look like? And what is that? That's a p orbital. Well, it's not a p orbital. It's the overlap of two p orbitals. But it looks like a p orbital, so what do we call it? A pi bond, because that, again, is the alliteration. If it looks like a p orbital through the internuclear axis, it's a p bond. It's a pi bond. If it looks like an s orbital, it's a sigma bond. It's that alliteration between them that you're looking for. We're not going to have to deal with this because we won't have transition metals, but you get the same thing with delta bonds. They look like d orbitals when you look through it. It's fun stuff. So, only specific combinations of orbitals look like s or look like p when you look through the internuclear axis. So only specific combinations of orbitals can be considered sigma and can be considered pi. We're going to talk more about how you get to those orbitals and how you can spot them in our bond line drawings next week. Have a great weekend. Oh, Alex, our president for American Chemical Society, would like to make a quick announcement.
Sure. Thanks, John. Hello, everyone. My name is Alex. I'm student chapter president of the American Chemical Society here at Salt Lake Community College. Next week, Tuesday, from 12 to 2, we will be hosting our annual Pizza and Posters event, which is where every year we attend the International ACS Conference, and this is just our way of hosting an event to let people know what projects that we have planned going towards the conference. So last year we had about 13 or 14 projects. We brought about 40 different students to San Diego. Oh, and it's a lot of fun managing and getting people there. But no, the main point getting out here is we have a variety amount of projects that we present, whether that's related to dental school or just organic chemistry, pre-med, pharmacy, the whole 9 yards. Whatever you can think of, we can bring a lot of those projects to the conference. So get involved. It's all stuff that you could potentially use on your resume, and it's just great that you can, or any sort of academic or professional career you choose to talk in. It's something that you can talk about and express interest and show your passion or whatnot and promote what you've done. And it's just all around, and plus you get a trip, so it's fun. But this is just our way of letting people know what we're doing.
Thank you, Alex.
Thank you.